Hi, I'm Dave Bodie, and in this video course, you are going to learn about the fundamentals of audio recording. This course will cover some basics like what is audio recording, what type of hardware is needed, input and output connections, what microphones do and which mics to use, recording instruments, software, and more. So, what is audio recording? Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. There are dedicated systems used for recording, editing, and manipulating audio, and they are referred to as digital audio workstations, or DAW. A DAW includes components like a computer, an audio interface, audio editing software, and at least one device for adding or modifying musical note data. The software is the core of a DAW system, but we'll talk more about that later. There are also portable battery-operated systems for recording audio in the field or on location, which we'll get into more later in this course. One concept that we will refer to several times in this course is signal-to-noise ratio. Signal-to-noise ratio, often abbreviated as SNR or S/N, compares the level of a desired signal to the level of background noise. This signal-to-noise concept can apply to many things in electronics and imaging, but in audio, background noise can literally be noise in the background, but it can also be noise generated by your microphone, noise from the preamp, noise from a guitar amplifier, or noise generated by the electronics in the analog to digital conversion itself. Getting more signal to noise means a cleaner, clearer recording, and it's a fundamental concept in recording. Let's take a look at this example. In this example, I've moved the microphone a good distance away from me, and I've also turned on my air conditioner to introduce some background noise. Now what I've done is leveled the audio so that my voice is the same as it would be if the microphone was closer. Now I'm going to move the microphone closer and let's check that out. Alright, now we're in the same exact location, but this time I've moved the microphone back to where it was before. The air conditioner is still on, I'm speaking at roughly the same level, and what you end up with is a sound where my voice is louder, but the sound that we don't want, the air conditioner, is softer. And that is an increase in signal to noise. We've gotten more of the thing we want and less of the thing that we don't want. Okay, here is a less extreme example. Again, the microphone is a good distance away from me and I'm speaking at the same level that I was before. But now we don't have a large noise source such as my air conditioner. Now we're picking up ambient noise in the room, which is some of my own voice reflecting off the walls. It's also the birds outside. Okay, there's no birds right at this second. It's also my computer running and any other tiny little vibration that's happening in this structure is being picked up more now that the microphone is further back and we have to boost the overall level to make my voice the same as it was before. Now that the microphone is back where it should be, you can hear that the ambient noise will have dropped off and my voice remains about the same. The tonal characteristics of my voice have changed a little bit because now you're getting a more direct sound rather than more of a reverberant sound where my voice is bouncing off the walls as well as getting a direct sound by the time it gets to the microphone when it's out there. And now you're getting more of the direct sound and much less of that. A very important property of sound is that it becomes weaker as you increase the distance to the sound source. The amount of change is controlled by the inverse square law, which states that when the distance from a sound source doubles, the sound level decreases by 6 decibels. The principle of the inverse square law applies to sound in a free field. A free field is a space with no reflective surfaces, and because there aren't any real places like this where you will be recording, the results won't be as exact, but they will be dramatic. The doubling of distance and 6 decibel decrease is a noticeable decrease, as a decrease in 10 decibels is considered to be about half as loud. The decibel is a logarithmic unit, so a 1 decibel increase is not a perceivable change. A 3 decibel increase is barely noticeable, and a 10 decibel increase is perceived as being about twice as loud. This is important because as you have the distance between the sound source and the microphone, you increase the volume by 6 decibels, which is a substantial amount. But what happens to the ambient sound in the room? The ambient sound in the room is nearly the same level throughout the room. This is because ambient sound has been reflected many times within the room until it's essentially non-directional. Let's say you are trying to mic someone outdoors, but there is a car running directly behind them. The distance from the microphone to your subject is 2 feet. The distance from the microphone to the car is 10 feet. At that distance, the person speaking is around 70 decibels and the car is around 50 decibels. By moving the microphone closer to the subject by 1 foot, half the distance, you will have increased the level of your subject by 6 decibels, but the car would only have increased by 0.9 decibels. If you cut the distance in half again and put the microphone 6 inches from your subject, they would increase again by 6 decibels, but the car would only have increased another 0.5 decibels. Making this change would have resulted in your subject being 12 decibels louder and the car being 1.4 decibels louder, which works out to making your subject about twice as loud without really increasing the level of the car. As you increase the signal to noise, you get a cleaner, clearer recording, more of the sound that you want, and less of the sound that you don't want. This is a fundamental concept, not only in recording, but working with audio in general. Something you need to think about every time you set up a microphone or when you're working with audio. You need to get the most signal to noise that you can.